It's a very interesting topic. Everybody talks about IoT, and in the satellite industry, IoT is always being mentioned. But the question is here, and I'm going to ask you first, Phil. IoT, what's the best way of defining it? Because as far as I can see, the understanding of what it is and what can be achieved is being lost.
Yeah, possibly, yes. So IoT, the general environment, is huge. So IoT is Internet of Things, and that goes all the way from wearables up to very large networks such as what we do with OneSub. So those would be utilities, smart cities, etc. I think, as you say, some of it's been lost. The Internet of Things sort of implies using internet protocols, but it doesn't necessarily mean things are connected to a public internet, but they're using those protocols. So, very simplistic overview.
Andreas, Deutsche Telekom, what's their view on this, the definition of what IoT is? Because, as I say, two different people give you two different definitions.
Yes, thank you, first of all, for having me here. And I'm having two different hats. The one is for 1M2M, so representing this group. So, and the other one is Deutsche Telekom, where we're also a member of 1M2M. First of all, I would like to explain shortly what 1M2M is. 1M2M is a standardization organization. It's built the same way like 3GPP. So it's built from the standardization SDOs like ETSI, ARIB. So it's a global forum. And it's providing standards for the so-called service layer or service enablement layer, and especially for IoT. So the name is still M2M, so the old name, but 3GPP is also named like 3G and not 5G. So anyway, so in the service layer shall enable IoT. As you said before, IoT, the application, and so if you look at it from a marketing point of view, it's huge. It's coming from variables, going down to trackers, and what else? And down to industry. And there are a lot of standards there. So I've also heard a lot about 3GPP, for example, during the last 2 days. And they are providing connectivity standards. This is the direction of IP, for example. But even more important for the connecting things is this service enablement layer. And this is something I think which is quite important. I heard this also yesterday for the satellite business. So you might have different customers for a satellite service, and you have also a service enablement there as well. You want to scale also with the different operators then.
Sorry, you mentioned about one M2M, but I didn't give Phil a chance to actually mention what is actually the Wi-Sun Alliance.
Okay. Yeah, so Wi-Sun Alliance was formed to use standards-based technology for very large-scale outdoor networks where cellular may not be the most appropriate technology. So our background is really utilities, so large-scale smart meter networks, and more recently integration of the distribution network, and also smart city technologies, usually using street lights as a canopy network, and then you can interconnect other devices. So for example, the City of London, if you go 1 or 2 miles northeast of here, Millennium Bridge is using Wi-Sun wireless mesh for their streetlight network. St Paul's Cathedral is illuminated using a wireless mesh network.
Okay. IoT, banded about, we talk about solutions for different sectors. Andreas, what is the biggest driver at the moment for IoT?
You mentioned smart cities. Smart cities is also what we see today, which is also a big driver for 1M2M. As you mentioned before, not everything is based on cellular. And this is also something where 1M2M kicks in. 1M2M, as I already said, is a so-called service enablement layer. It's like the same way, like this mobile broadband stuff, the smartphones today, a developer of an application, of a service, for example, on a smartphone, he doesn't need to take care on how to access the sensors or how to use the connectivity. So if you send a message with WhatsApp or Viber or whatever messenger, you don't need to adjust which connectivity to use. So that actually the operating system as such, which is kind of service enablement layer, is taking care on which connectivity to choose. And in the whole IoT area, especially for smart cities and all those different sectors, variables, if you access, for example, a light or a temperature, it's always a temperature, whether you send this over Wi-Fi, cellular, or satellite. And this service enablement layer, this what 1M2M doing, is specifying this in a way that the developers are able to access, for example, those data and those connectivity options.
What do you think, Phil?
Totally agree. And an example of this is, so with 1M2M, Wi-Sun Alliance is actually a liaison with 1M2M. There are profiles for a number of different device types, streetlights, for example, that will run over a Wi-Sun network, LoRaWAN, or NB-IoT. So for the people deploying, they can choose any of those underlying low-level communication technologies, but the data model is still the same, so the control is still the same. So in Europe, UK particularly, 1M2M models for water meters are very popular, and that typically LoRaWAN.
So let's move this on a bit. Let's look at smart cities, because that's the ultimate goal. We hear a lot of talk about smart cities. A lot of people don't know what they are, but we're sort of going to try and cover this now. But what is the progress in this area? Are there actually any examples that we can talk about and say, this is the model that works? Phil?
So as I mentioned, in the UK, there are a number of cities. So I think Bristol was fairly early on in the adopting initially streetlight network, Glasgow, London, City of London, as I mentioned, about 12,000 streetlights or so in the City of London. And then they use that for connectivity for things like traffic flow monitoring, smart signage, smart parking. In other countries, so US has got some very large smart meter networks. I think, as I said, our background is smart meters, and certainly the electricity industry is probably in its second round of smart technology. They have a long background of using M2M type technologies for SCADA applications. But I think we're seeing quite a lot of growth now. I think certainly the utility industry is a mature view. They've experienced this. There's been, you mentioned on the previous panel about cybersecurity and hacking. And certainly utility industry sees a lot of hacking attempts on it. I think there's still education needed for cities in the requirements of cybersecurity, but it's definitely making progress.
So Andreas, I'm going to slightly fine-tune this. What Phil's talking about, lighting, smart parking. But there's a lot more we want out of smart cities. So how are we going to cope with the demand for the vast range of applications that smart cities are ultimately going to ask?
So I'm coming from the standards area, we provide, let me say that we try to enable something, scalability. If it comes to smart cities, that the market is a bit different to, let me say, mobile broadband. Or mobile broadband is quite easy because we have a shop, for example, as DT or any other operator, and then the customer is rushing in and say, look, I want to have this smartphone, I want to have a rate plan for this, and then everything is done. For smart cities, it's a bit different, because there is some civil servant or something, someone who is deciding on and doing a project and evaluating something. And then there's the market outside is huge, on IoT. So of course they think about standards, for example, sometimes on okay, this need to be based on LoRaWAN or cellular or whatever technology, and then this is all fine, and they also provide this. But if it comes then to the service enablement layer, it's coming a bit, let me say, difficult, because it's not very popular. So 1M2M is probably also not that widely known. There is also other technologies out there on proprietary basis, and then the decision for those projects is a bit difficult. So as you said, even in London, it's quite popular. There's also an intelligent transport service which was based on 1M2M, but it was not widely, let me say, advertised. So while 3GPP is widely known in the connectivity area, so this is not so widely known. But it's still growing. We see also deployments in France, for example. We see a lot of deployments also in Korea and also in India, for example, that is based on 1M2M. But it's basically what's then advertised is not the standard itself, it's the product or the project itself. So I would wish, let me say, that we see more implementations which are based on standards, but this needs, let me say, some investigations by those companies implementing those solutions.
I'll come back to the standards a little bit later, but I want to keep on pushing Phil here. How far can we go with these smart cities? What I'm trying to get at is, what is the ultimate goal? What is people's vision? Because with that comes data challenges. And so I want to know where we're going with this.
Okay. If you're talking about data challenges, I'll give you a statistic. Tokyo has 29 million smart meters on their electricity network, and they are currently doing 15-minute reads, and they want to do 5-minute reads of data. So if you work out, it's a huge amount of data. So what do you do with it all? The idea is that it should be processed at the edge. So you don't store huge quantities of data, because what do you need it for? You actually need it for, apart from revenue metering, you need it for control of the network. So I think there are, within cities, and again, we're talking about sensor networks here, and there are other needs, as you mentioned, like wireless broadband, for example, or Wi-Fi networks, which are different and have different requirements. So I think it's important that you use standards-based transport networks, and I'm going to keep coming back to standards. I'm afraid it's important that you have a common data model, because you're not quite sure right now. So say somebody wants to do street lighting, and then they want to do traffic management, but if you have silos, application silos, you can't link those two things together. So having a standardized data model means that at some time in the future, you might want to control your streetlights, adjusting by the amount of traffic flowing, for example. So having that capability built in from the start so that the applications can tie together is really important, I would say.
But Andreas, you've got Phil talking about standards, and you really are coming from the standards angle. And we know from historically over the years, people adopting standards can be very difficult. I mean, what challenge are we seeing here? Because, we're at a satellite event. You've got, everybody's sitting here, and, we're looking at you for a definitive answer.
I think depends a bit on the value chain, and what is your product. So I've seen also here companies, and I'm coming from the broadband area and different area. It's not, satellite is not my main business. But also it depends on the value chain. If you look at, for example, again on these mobile phones, because so we have the customer like me, using the mobile phone, but we have in the value chain, we have also the application provider, for example, the application, this nicely square stuff on the mobile phone. And these applications also using sensors, for example, on a smartphone itself, and the access of those applications is the same, whether it's a brand X, Y, Z smartphone. And this is where we need to go also in the IoT area. It's not the way how we access the sensor. It's about the application itself. As you said before, if we can combine this data from the street lights, from traffic flows, and other areas, pollution sensors, temperature sensors, and so on, then we can really create an added value with IoT. And that's where, let me say, these standards are hooking in. But as long as we see competition, on a way, I have the most beautiful API or something, even it's more, and it's a bit more challenge on them, is they have the same API on their way, even if it's not that beautiful. And we can see a lot of big companies, tech companies rushing in, also in the past, who failed with their beautiful APIs because the customer wanted to change also and interchange. And the competition should not be on the beautiful API. The competition should be on the best solution for various sectors, being it smart cities or being it, variables or whatever.
Now, you mentioned security earlier, and, so I want to touch on this. So we are talking vast quantities of data. As cities become smarter, there are frailties in the security system. How are we addressing this? How are we going to address this?
Okay, so as I mentioned, and I'll probably keep mentioning, Wysun came from a utility background, and utility communication networks are critical infrastructure networks. You hack a smart grid, and the consequences can be dire. So with the Wysun protocol, we use public key, PKI. So every device has got a certificate, and they negotiate and authenticate devices on the network. We are also using sort of link layer encryption as well. So very similar to what you might do on a cellular network. Coming back to the standards, the fact that you're using a standard for certificate format, device authentication, the streaming encryption means that those are very well understood. Any problems that they might encounter can be fixed relatively quickly. Standards organizations are also involved in IEEE and ISO as well. So standards organizations, for example, with the link layer encryption, currently most people are using something called AES 128. It's not secure with quantum computing, so moving to AES 256, which is much more secure. And the standards, following standards means you can migrate, you can use the same technology across multiple transports. Does that sort of answer the question or not?
Well, if I believe it, yes. But I mean, the generic nature of cybersecurity attacks means that, we've seen companies who say it's complete and they've been hacked to death. But that comes back to a comment that was made in a previous discussion, which is people attack the weakest link. Yeah.
So there is a US utility company who commented they were getting 13,000 hacking attempts a day on their network. Some of which was coming through the smart meter network, some of which was trying to find ways into the IT system through the back office. So those attacks are happening all the time. How do you protect against them?
How do you protect against them, Andreas?
So the security question is on the agenda of every meeting and discussion panel. So I need to laugh a bit because there is no easy question to yes or no. I think the security question is a system question, an overall question. You need to look into various stuff. Which protocol to use, which ciphering algorithm to use, and so on. Sometimes I think the most important point I would like to make here is simply if the previous speaker from Airbus in the morning said, for example, also standard-based for military. I think it's good if something is standard-based. For example, because if it's standard-based, you know what you're doing. Even though you disclose, for example, something security, for example, if you go to ciphering, we can pretty well, let me say, publish an algorithm, for ciphering, as long as you don't publish the key for it. So it's the same for your door lock. If you can publish the blueprint for your door lock, as long as you publish your key from home, your home is safe. So you have the possibility, at least, to, let me say, also have test specifications for security, and even you can certify something afterwards, And as long as it's standardized, you can check it, and even if there is a vulnerability, you can fix it. You know how many devices, how many systems are affected. I think this is a good approach. Whatever it is, then on the detailed level, I think if you go for some standardized security, it's the best way. Of course, you can complement it on top then with something proprietary if you want, but in fact, it's better than having some, let me say, there's also discussion about messenger services now in Europe, and it's the same, then if some companies just claims we have the best security and you can't check it, then it's always bad. So openness, transparency, and standards I think is the best way to approach this. And whether something is safe, you need to look at the whole system as such.
Now, Phil, we were talking before, during the coffee break, and you were talking about using AI to combat and look for intrusions in the network. Yeah. Tell me a little bit more about that.
So, again, with the Wi-SUN network, we're using IPv6 to every device on the network. So therefore, you can do traffic analysis to every device, and you can look at the sort of traffic, and AI works particularly well for that. So collecting data. So you've got a smart meter. It's supposed to send data once every 5 minutes, and suddenly it starts doing port scans, or it starts talking on a port that it's not supposed to talk on. If you're monitoring your network and AI works well for anomalies, then you can think maybe that device has been compromised in some way or another. So, and when you're talking about these very, very large networks, several million devices, yet you can see every single device's data traffic, that provides a very good use for AI. It's also, while you're talking about AI, devices have bugs. So you know what sort of network traffic you're expecting. You see something unusual, or the AI sees something unusual, then it can highlight that and somebody can take a look at what the problem might be. Again, utilities are also using AI to look at faults on their distribution network, or to do preventative maintenance. If you start seeing unusual electricity consumption on the network, or suddenly, you're seeing excessive water use, then maybe you've got a leak. So all of that can be done with AI.
So just a quick sort of jovial bit here. You're talking about Tokyo, and they're checking the meters every 5 minutes. Why can't we check the meters correctly in this country?
That's a very good question. It's sort of one of the embarrassments of Wi-SUN is that there are some Wi-SUN networks here, mostly in smart cities, some on distribution networks, but not the smart metering network.
I'll let you off on that one.
Thank you.
So I want to go back to Andreas, the IoT. How far can we go on this? Are there any limits to what we can deliver with IoT? And if there are, excluding standards, what is the challenge, the key challenge?
Excluding standards. I think personally, I'm a fan of it, of IoT. I'm also privately, doing some stuff at home, and I'm a real fan. So if someone is ringing on the door, so I get the message, and everything is linked together, and you by developing something, you discover what else is possible and what else is useful. It's really an area I really like. Yeah. If it goes to a product, and scalability, then coming back to standards, although you excluded them, the use of standards is really something which is necessary, because otherwise, you can't cover the whole value chain. So we have a lot of customers, who are using our connectivity options. We have many options, and they really need a lot of experience how to use this technology. And for this to enable them or to make it easier for them, for example, for our satellite, we also provide them satellite connectivity via partners. So we offer them a solution via 1M2M. So at least we make it easy for them to cope with the connectivity option, so that they have just from the network side, not from the device side, that they from network side, they just look on a unified interface towards the network. And that's what we provide them from our side. So everything else on IoT, I think the sky is the limit,
So, yeah, and maybe adding to that and tying satellites and the IoT stuff we've been talking together, there are things, for example, remote oil fields in Alaska where you are not going to have cellular connectivity, where a satellite is the only connection. There are projects going on with off-grid connectivity, so where you've got renewables, solar, wind, that are servicing small parts of a country that don't have cellular connectivity. So you have an IoT network, which you need this unsupervised network operating, but you need to collect the data and pass it back centrally. So then satellite is the perfect connection mechanism for that. And you need the IoT because you don't necessarily have somebody on the ground that understands and can do the fault finding.
Yeah. But in your opinion, how far can we go with this? What is the actual limit of IoT, or isn't there one? Give us a prediction for the future, Phil. Where are we going with this?
Are you talking in terms of the amount of data, or how it influences our lives?
How it influences our lives?
I think things like autonomous vehicles are going to be a major influence on our lives, which as I get older, I get more cynical and skeptical actually about how this stuff is going to work and how it affects. There are things that are improving quality of life right now, though. So smart water is an example of one of those. We need to be careful about resources. So smart grid is good. The integration of renewables into the grid is really important. So for me, there are priorities in achieving IoT, and those particularly relate to energy, I would say, and water.
Maybe to follow up on this one, because I think from impact, so what I can see, I'm a fan of this IoT stuff, and I'm using it as well at home, for example, in my home country. So we have some electricity providers also. They're just a few, 1, 2, 3 or something like this. They're providing dynamic electricity prices based on the head price of the electricity. And this also requires, of course, a smart meter, And while people have thought in the past, you need to go to your electricity meter and you need to look at the electricity price and then I switch on my washing machine or whatever, it's not the case, it's about automatism, And with this electricity, this dynamic electricity prices, for example, so we see also in the market already solutions for management, for example, for heat pumps, heatings, and so on, which are switched up based on the electricity price. And if you look at, there are some the electricity prices, at least in continental Europe, sometimes, or at least in Austria, for example. This year during the summertime, the electricity prices have been, sometimes the day-ahead prices have been negative during the day. So you get money if you consume electricity because there's so much renewables now in the market. And this is a perfect, let me say, time to charge your car, for example, and this is something I think makes our life and impacts our life in the future, and the basis for it is IoT in the back, and based on different connectivity options, being it Wi-Fi, LoRa, cellular, satellite, whatever. And what's also necessary, because you asked for the challenge before, is also that the data models are the same. This is particularly important because if the data models are not the same, then simple temperature values, temperature of water, temperature in Fahrenheit, temperature in Celsius. So if you tie this together and if you standardize this, unify this, then this exchange is possible, and then the sky's the limit.
I mentioned earlier, where there's a will, there's a way, but just generally, geographically, Phil, where are we? Who's ahead of the game on all of this? Where do we sit in? Where does Europe sit in this? Is there somebody out there who is so far ahead of us that we're all looking at them thinking you are the model that we should be adopting?
I think it's more related to industry sectors, actually. I would say electricity industry generally is further ahead than most in adoption of IoT, partly because of the history coming from, SCADA systems, and some of the, repercussions of events. So, for example, Fukushima in Japan changed the nature of IoT in the utility industry phenomenally, because Japan went from energy surplus to energy deficit overnight, effectively. And again, we come to standards. There used to be very cozy relationships between the utility companies and their suppliers, and then Japanese government insisted that there should be an open tendering process and standards-based technology and interoperability. So that was just Japanese model. If you remember, mid-2000s, there was a big power outage on the east coast of the US that brought about the EISA Act, which was investing in grid modernization. So the US has plowed a lot of money into bringing their grid up to date. So I think that's been happening in those places. The rest of the world still maybe catching up, but doing quite quickly. There's a huge smart metering program going on in India at the moment, where there's still large chunks of the population don't have power at all. So that's an added problem. And it's varies by sector though.
Andreas?
Yeah, I think this what you pointing out here is really that we see some focus points, and of course there's some kind of niche markets. Of course, the utility sector is something which is also growing up. Even within the utility sector, I see different standards sometimes emerging. But the huge number of devices, they don't make this transparent. But still, we are talking about a limited sector. If you talk about IoT, because with the utilities, it's about gallons, liters, cubic meters, or whatever. It's about kilowatt hours, watt, or whatever. So the number of, let me say, parameters are limited. And even though, let me say, you have in the house or in different sectors or in cities, for example, you have the same parameters, those are the different. This, let me say, from marketing point of view, utilities is one of those categories you see IoT. But if you see it overall, then these sectors need to work together and need to be harmonized. this is something where 1M2M kicks in, because 1M2M has this, let me say, tearing down the silos approach and offering generic data models, which can be used by different sectors and different verticals. And if you ask about geography, so what we can see, although it emerged out of Europe, 1M2M, the biggest adoption we see is in Asia. So we see this in South Korea, because they have there's a government mandate on this standard, that this should be as a recommendation, which powered it up a lot. Or the market penetration went up there quite a lot. And nowadays also we see a big uptake, for example, in India, because India, with TSI, they joined this partnership program, and they took this also over. And there's also a recommendation from the authorities to use these technologies. So in this sense, also regulatory and recommendations from the government can also help, let me say, to overcome these challenges of different silo applications. I think something similar we had with GSM, then also a couple of operators joined together, and within Europe, GSM was developed, and then it spread all over the world.
Well, thank you, gentlemen. Are there any questions?
Yeah. I understand the whole concept of IoT standardization, how critical it's there, and why hundreds of millions of devices already, because like the smart grid and all this kind of stuff. And that's great, Zigbee, LoRaWAN, and all these other technologies. But those are great for managing fixed assets. Now, on the satellite side, where we're dealing, is that the solutions have not been standard-based. They do omnichannel proprietary, they're off-grid. And good. Now, with the new work that's going on with NTN, especially again 5G, and NTN also with LoRa initiative, you foresee that, everybody talks about the billions and billions of devices that have to be deployed in IoT. Do you think that part of that will now start migrating toward these NTN networks? Because after all, when you look at AST networks or any of these other networks that are deploying 5G over satellite, it's easy to say that anything that was off-grid before is no longer off-grid. You have 5G everywhere, and that's going to be covered by these satellites. So will IoT, 5G, NTN become the big market play? Will that be the actual driver of revenue in that market? Where is this after the consumer? Can you their regulations?
Yeah. So now I'm having the head of a carrier, of an operator. So I think what I see is the perception, let me say, a broad perception of if there is something written IoT, then it's IoT inside, or NTN or something like this. So cellular side, there's NB-IoT. A lot of people said, okay, with NB-IoT, we have IoT. In fact, if you look at the figures, and the devices we have in the market, GSM is the predominant, let me say, technology for IoT devices. So they are using it. It's just, let me say, just another connectivity technology. I think I also thought, okay, well, the 3GPP tried to, let me say, solve this problem also by providing technologies like NB-IoT for certain markets. But in fact, it's a big variety. If you have a streaming with a video camera with data from, let me say, observing parking spaces, it's also IoT. But you need other technology. If it comes to, let me say, some oil drilling facilities somewhere in Alaska, there is no cellular coverage at all, then satellite comes into place, So in fact, we need a lot of different technologies, connectivity technologies, to make this happen. And of course, we have these huge numbers predicted by Gartner and other companies and analysts. But the technologies, these connectivity technologies are there, it's good. So the link between the ground station and the satellite is working, between the base station and the modem is working as well. But the biggest challenge I see is for getting even more, let me say, connections is still this point that you cannot go to the shop, you know, and buy a utility meter which is working together with your heat pump, you know, and therefore we need these standards, you know, to enable this, or we need to have more implementers and companies taking over standards, you know, then we all, I think, can go towards this shiny high numbers, you know, of connectivity options and all the different connectivity options.
I also think data aggregation is really important. If you look at the cost per node, then obviously with a satellite connection, you're not going to have it in some low-cost IoT device. So having the ability to do data concentration through border router, where you can collect lots of cheap nodes and then do the satellite uplink of, you know, several hundred or several thousand nodes.
You want to operate as much of the pack.
Yeah.
That's okay. It's actually more on the off-grid things that are currently operating today. The IoT industry now all of a sudden having portions of the provider solutions or about be on grid with the forgot the YG. I thought so. It's and what I know is that you can actually get these 4G, 5G devices that can run autonomously for I'll do like 4 to 5 years in an IoT mode. So it's actually very interesting that was like just they have an integrated battery. The connected cow was.
Yeah, it was.
It's about thirds of how it's like, you know, it's an interesting concept.
Well, and that sort of, so smart agriculture is actually a really big topic, interesting topic as well. And a lot of that happens in remote locations where there's no cellular connectivity. Well, yeah. So, you know, if you're a sheep farmer in Australia or cattle farmer in Australia, and you've got this huge herd that is going across thousands of acres, you want some way of monitoring their status and their well-being and where they are.
So you next why not 100 cows and then see it.
Well, I would say use Wi-Sun or LoRa better.
Yeah. Maybe if I follow up on this, you mentioned these technologies like NTN or NB-IoT and so on, and running on a single battery, AAA battery or AA battery on 5 to 5 years. This is the marketing claim which was sent out also from my colleagues, and I was also working at GBP. In fact, what you do is like you sell a car and you say you can run up this to up to 5 years, you know. But it depends on how you drive, or it's like driving a car, you know. The Tesla also has, 1,000 PS or horsepower, you know, and you can run this car. But then you can't go 600 kilometers, you know. You can just go 600 kilometers with a Tesla, you know, if you drive not more than 100 kilometers an hour. I don't know how many miles these are. And the same way with those technologies. And what you see in the market is really that companies are approaching us, they come back and they say, look, you promised 5 years, and then we need to tell them, okay, yeah, but if you send the data every, 10 seconds, you know, then you cannot run it for 10 years, you know, and we have a lot of effort to teach this. And this is again coming the service layer into place, you know, this, if you would have some implementation on the modems itself, you know, which, let me say, configurable by the operator or by someone else or one partner in the value chain saying, look, I offer you something, and, you know, and the device is just sending every 10 minutes, you know, then we would remove a lot of, let me say, problems right from the very beginning from those companies developing such solutions. We have also solutions that are also in the utility sector. We also had some learnings in the past. I think it's already 10 years. So there was an operator in Norway who faced a problem because 400,000 smart meters, you know, they started to reset themselves all at the same time in a very tiny area. Why? Because the company implementing the smart meters, they had some code inside the smart meter saying if you lose the connectivity to the back end, just do a reset. So like all the coders do, like if something fails, you do a reset and then try look what happens. But if you do this on the other side, of the device side, they created a signaling rush and made the operator collapsing the network for 48 hours. So and this is the reason why this service layer stuff is that important, that this is coming into place as well. And it's making the connectivity more easy to handle, and it removes a lot of problems for those companies being good in doing applications, connecting things and doing services.
Thank you. Any other questions? Well done, gentlemen. Thank you very much. Thank you, Phil. Thank you, Andreas. Thank you for joining us. Really enjoyed that. Thank you.